Good morning everybody, and today we are going to begin with a new topic from operating system, and the topic is process management. It's a very interesting topic and it will help you to understand what exactly is happening in the background whenever you are trying to execute an application in your system. Let's start. What is a process? It's a very important question. Well, process is a program under execution. Whenever there is a program that is executing, we call it as a process. Let me give you an example. If you are executing a program, say Microsoft Word, MSW. Okay. So you open the application Microsoft Word. So what you are doing? You are typing a document. What you do? You first type a document, and maybe in the later stage you may need to check the spelling. Check for spelling. Check for spelling mistake. Somewhere in between you may try to change the font. Okay, you want to highlight the heading. Somewhere you may try to change the color. So you are opening a document, Microsoft Word. You are typing a document, you are typing matter. Once you are done, you are doing different things. What I want to say is, whenever you execute an application like Microsoft Word, many small processes gets created in the background. And these processes will be ready for you, okay, waiting for you to be used. So while I am typing a document, these processes are ready, but they are not used. So whenever you are using spell check utility, a process that takes care of spell check starts. Whenever you are changing font, a process that is changing the font will start working, and the same case with any other activity that you would like to do with the document. So whenever you execute an application, it gives birth to many processes. Okay? So this is how you can view, you can imagine about a process, and that is all about the actual existence of a processing system. It is a program under execution. Regarding process, when we discuss, we should study the concept of process, what exactly the process is. And the most important thing that you should deal with is process life cycle. Okay, so how the processes are scheduled, what are the operations which are done using processes, what are cooperating processes, what are inter-process communications, okay, and the communications with respect to the client-server mode. To begin with, okay, let's understand, okay, what are the basic requirements for a process. Okay, whenever you execute application, the process must be created, and a process that is created should find some space in memory. Now when I talk of memory, okay, I talk of main memory. Process should find some space in main memory. Process should find some space in main memory. Now what do you mean by this? That means the process, whenever it is created, it should be supported by some data structures. Example, the program counter, the stack and the data section. Okay. It will have its own data structure so that it can do the computations that is being told. This is a layout of a main memory. This is a layout of a main memory. And if I am talking about a process, okay, the process will have a dedicated place in the memory. So if we draw the layout of a memory, there comes into picture a stack part which stores the temporary results, the intermediate results which are generated during normal execution, the process itself, the heap area which is taken care of by operating system, the data that is to be used for processing, as well as the text part. So whenever I am talking about a process, it is very important to first understand the life cycle of a process. So when I execute an application, many processes are getting created. Okay. So all those processes which are getting created, okay, they come in a new queue. So they get populated in a new queue. All the processes are already created. Now, all the processes which are created will never come in ready queue. Why? Suppose if I am executing some application and suppose 10 processes are getting created. To begin with the application, process number 8, 9, 10 is not required. Only process number 1, 2, 3, 4 is required. So, until and unless the process 8, 9, 10 is not required, you will never touch the process. The process is created, but you don't require that process right now. Second thing, out of 1, 2, 3, 4, first 4 processes which are created, which are required now, only 1, 2, 3 process has acquired the number of resources that it needs for execution. So all processes are created. You executed an application, all processes are created, but all created processes will be in new queue, and only those processes will come in the ready queue, okay, which acquire all the resources which are necessary for execution. Now, suppose there are 10 processes created, out of which 3 processes came in ready queue, okay. So I'll say what has entered inside is total 10 processes, out of which I need 3, out of I'll need 4 processes to be executed, but only 3 processes have entered into ready queue because only 3 processes have acquired all the resources which are required for execution. Okay. Out of these 3 processes, process number 1, process number 2 and process number 3, okay, the priority of process number 2 is 1, the priority of process number 2 is 2, and the priority of process number 3 is 3. That means what? Process 2 has got highest priority. All 3 processes are ready, but all 3 processes has all the resources which are required for execution. But out of all these 3, the priority of process 2 is highest. So which process will be taken up for execution? Which process will be taken up for execution? Obviously, process number 2. So in short, what I want to say is, whenever you execute application, maybe MSW, n number of processes gets created. Out of n number of processes getting created, only those processes are brought in the ready queue which acquire resources, because without resources no process can execute. So out of all those processes which are ready for execution, since they have acquired processes, only that process will be taken for execution under CPU. So running means who is doing this? this is done by CPU. In short, the microprocessor. So only that process will be brought in under CPU which has got all the resources already acquired and who has got the highest priority at that time. So that process will win the bid, will be executed under processor, and while this is happening, there is always possibility that the execution that is going on under CPU may halt. Now what are the reasons? The execution that is going on under CPU may halt, and various reasons. Totally there are 3 reasons, majoritarily there are 3 reasons. Reason number 1, okay, what will happen is, maybe there are 3 processes, okay. Generally, this is process number 2, then come process number 1, then come process number 3. So what CPU says, okay, I can complete the task only when I will complete all these processes. So I will complete this task, then I will come to this task, then I will come to this task. And let me give 2 seconds to each task. So there is a quantum of 2 seconds given to every task. So when this process is executing, if it completes its execution within the stipulated time, it is nice. Process 1 will come in and then process 3 will come. In case if process 2 need more time, then what will happen is this process will be swapped out. It will be swapped out due to timeout operation. So this is the first reason when the running process will be swapped out, will be thrown out, and it is the process is thrown out, it is brought in ready queue. So what? After that 1 will execute, after that 3 will execute. So again the process 2 which was thrown out, since its quantum has expired, will be taken up for execution. So reason number 1. Okay. Reason number 2. Reason number 2, okay, is the process is already running under CPU. Suppose suddenly the process says that, okay, now suddenly I require 3 resources. I was having 2 resources, I was happy with those 2 resources, but now the situation has come, I need 3rd resources. But the 3rd resource is not available. Maybe it is used by many other processes. So in that situation, CPU says, I can't, waste time on you now. Okay, either you get ready with the resource, or please go out. Please go out. Acquire that resource, maybe input resource, maybe output resource. So this is the second reason the process will be thrown out in the waiting queue. Once the process acquires that input or output resource, it again comes in ready queue, and then it is again taken up for execution. The third reason because of which the process will be thrown out of the running queue will be, okay, if suppose say P1 is P2 is already executing. P2 is already executing. What happens is one more process P4 which acquires additional priority higher than 1 plus. So one more process rushes in, and that process has got 1 plus priority. The process with highest priority is 2 here. But I can see there is one more process which has come in ready queue now, which is having higher priority than process 2. Now in this situation, process 2, which is already having higher priority, will be again interrupted and will be thrown out. Will be again interrupted and thrown out. you will see process P4 getting inside the CPU and executing. So the three reasons because of which the process will be thrown out are: one is when the process requires additional resource and it does not have that resource, it will be thrown out in a waiting queue. When the process quantum expires, it will be swapped out again in the ready queue. When the process executing, is having a priority which is lower than the newly brought in process, then also the lower priority process is interrupted, the higher priority process is taken in. And if nothing of these things is happening, like the process is lucky, there is process is executing in stipulated time, there is no more higher priority process coming in ready queue, as well as all the resources required for execution are available. In that case, process happily executes and goes into the final stage, that is called as terminated. And what do you mean by termination? It will be removed out of memory. It will be removed out of memory. So that is all about the life cycle of a process. To conclude, whenever you execute an application, lot of processes get created. All those processes are then brought in new queue. Out of all the processes which are getting created, processes with the highest priority which are required for a current moment to be executed are brought in ready queue. All the processes which are ready queue, must require all the resources which are required for execution at that moment. Out of all the processes which are ready queue, only a process with the highest priority wins the bid is brought in running queue. And if the process executes within time, if the process is having the highest priority, there is no other process coming in ready queue with a higher priority other than the process which under CPU, as well as the process all enough resources for execution. If everything goes fine, process happily executes, completes its task, and finally reaches in terminated stage. And once the process is terminated, that means it is removed from memory. It is removed from memory, that means more number of processes can be acquired, and this is how the story continues. That is all in this lecture. We will see more of the data structures are used in this process life cycle in the next lecture. Thank you. स्टॉप कसं करणं?
पण हे स्टॉप हे आता रेकॉर्ड कुठे ह्याच्यात चाललंय
सर कंबाईन